and welcome to Geeks for Geeks. Today, we would be discussing the problem alternate positive and negative numbers. So, as the name suggests, we need to create an array with alternate positive and negative numbers, and we need to maintain the relative ordering. This means that suppose this is 1, 2, and 5, then 1 should appear before 2 and 5, and 2 should appear before 5 and after 1. So the ordering in the original array and the ordering in the new array or the modified array should be same in both the cases. Now let us move forward and evaluate the sample test case. So the first positive number is 9 itself. That is why we kept here 9. The next positive, then the next negative, first negative number is -2. That is why this is 10. Then the next positive number, because first we process positive, then we process negative, then we need to again process positive. The first positive number is 4. That is why this. Then we need to find again negative. So this one, -1. Then again positive, that is 5. Okay. Then again negative, that is -5. So -5. Then positive again, that is why 0, 0. Then negative, and it is negative. Then again positive, we have it here. So we can see that we need to maintain the relative ordering and we need to write it as it is. So to solve this question, it is very easy. What we can do is, and the sample test case would solve the purpose. What we need to do is, at each point of time, we are trying to find the first positive, then we are trying to find the second positive that appears in the array. Okay, and same goes for negative. So what we can do is, we can take up this number 9, and then we can write all the positive numbers, like we can segregate the positive and the negative values. So 9 and 4, then 5, then we have 0, and then we have 2 itself. So 9, 4, 5, 0, and 2 is done. Now we have the next negative one. It is -2, -1, -5, and -3. Now what we can do is, we can take up this element from the array, and next we can take up this element from the array. Again we can take up this element of the array. Again we can take up this element of the array. Again we can do this. 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 At the end, whatever would remain, we would just add that. So now we would do the same thing in the implementation also. We would take the first element from both the arrays, then the second element from both the arrays, and the third element from both the arrays, till the minimum number of elements. Like first the positive array has 5 elements, then the negative array has 6 elements, or suppose 7 elements. So in this scenario, 5 elements would be taken from both, and leftover elements from the negative array would be added after that. Okay, so now let us move to the implementation and you would understand it much better. Now, what we would do is, we would first have the negative and the positive array. So we would declare vector of int of the negative and the positive one. Next, we would iterate on all of the array elements, and then we would try to segregate and keep it at the desired position. So we would iterate over it. So for int I is equals to 0, I is less than n, and I plus plus. We can use a for each loop also. So now you can say that if ARR of I is less than 0, that means if it is negative, so we would push it to the negative array. So neg of push back itself, and then we have ARR of I. Then we have the else condition, where either it is 0 or it is the positive value. So pos dot the value push back, and we would ARR of I itself. Okay, and then we go down. Now we initialize the array. So for int I is equals to 0, this is the pointer to the first negative, then j is equals to 0, and then k is equals to 0 would be the pointer for the resultant array. Now what we would do is, we would keep the answer in the ARR itself. So we won't do any explicit thing, we would just modify the original ARR array only, which is stored. So while I is less than neg dot size, okay, and then we would have while j is less than pos dot size. So why are we doing this? We are doing this, suppose we have in the negative array, we have the elements as -1, then -2 and -3. But in the positive array, we have just one element. So we would just go, this corresponding position would be going till the first element. That is why while we have elements on both the arrays, then only we would move forward. So I would just comment it, or rather delete it. Okay. And then we would come to the first position and we would say ARR of K is equals to cos of J. And then what we would do is we would do K plus plus and J plus plus. But instead of that, what we can do is, to make a short form, we can directly do K plus plus and J plus plus at this position only, where what would happen is, after using the kth value and the jth value, it would increment after using. It is a post increment operator. You can learn about it if you don't know. So ARR of again K plus plus is equals to first positive, then negative. So I plus plus itself. Then we go down. Suppose the elements are left in the positive array. So we would say while j is less than cos dot size. Okay. So what we would do is, so ARR of K plus plus is equals to cos of J plus plus. And we would do the same thing for I also. So for int I is less than negative dot size, and we would do ARR of K plus plus is equals to cos of I plus plus. And this would be neg. Okay. And we have it here. Now just compile and run and see how many errors are we making. Now I can see that I'm not making any errors. Now let us try to submit this and see if we can get an AC or not. So yes, we got an AC. Let us now talk about the space and the time complexity. Let us first talk about the time complexity. So here we are iterating over each of the element. So for one element, we are just comparing and pushing back. So pushback has a constant operation and comparing is also a constant operation. So for each element, we are doing constant operation. So for n elements, we are doing an operation. And then we are iterating on the elements. Okay. And then just we are assigning and moving forward, which is a constant again. So the number of elements, this would be just the number of elements in the original array, the sum of it, because the positive and negative numbers we are getting from the original array itself. This is again big O of n. Now we are using two auxiliary arrays to save the values. That is why the time complexity would be big O of 2n, constants are ignored. So that is why the space complexity is big O of 2 and constants are ignored. So that is big O of n. Now, if you were here till this point of the solution, consider liking the video and commenting on the video, either understood or one, to increase the reach of the video. That's it for today. Thank you and have a nice day.